Let us begin new lesson, relative dating, that is lesson number 2. So I just want to ask you, how can one know the age of the rock by looking at the layers? Do you remember last year, I think in the class, did we do anything for fossils or with the clay?
Yes, I remember.
Yes, I remember.
We put different layers of clay, and I told you something. Do you know that? How can I know the age of the rock, of any rock? Any idea?
Fossil.
Okay, by the age of the fossil. All right. Anything else? Now see here. Let me show you. This lesson with the name, you must know how to draw everything. When you see the name, like example, if I see the name here weathering, I know that it is breaking up of rock. When I see erosion, I know something is flying. When you see this word relative dating, that means, like, let me just draw, okay, brown color, dark brown here. This is the first layer. This is the second layer, okay. You can see some different colors. This is the second layer of the rock. And 1 minute. This is the second layer of the rock. Okay. Because of erosion, there were particles, they came. Then again, they came here and they settled. On that, you have one more layer of rock. It's not green in color, but I'm just drawing with green so that you know that you have different layers. And then finally, there's one more layer here. Okay. Now let me know, Zishan, I will ask you the question. Which is the oldest rock here? Which oldest rock? Excellent. If I write here A and I write here B, I write here C and D, I will say that A is the oldest rock. And Mashtulin, which one is the youngest one?
D.
D. Excellent, Mashtulin. D is the youngest one. A is the oldest and D is youngest. That means because first A layer came, then the B layer came, then the C layer came, and then lastly D. Okay, according to you, where do you find many fossils? Okay, I can find fossils in, it could be any layers. We cannot say like in plants, in the soil, you see the fossils only in the first layer. No, and second, very few, third, you don't. But here, all of the layers, they have fossils in it. This is called as, and when you compare them, this is called as a relative dating. So do you understand what are we going to do in this lesson?
Yes.
Okay.
Yes.
Yes, coming to the next part. Okay, fill in the blank that you think completes the following. An example of something young, an example of something old like mountain, an example of something that is horizontal, anything what is horizontal, plane, that is older than you is anything. It's just not your, with, you have to write any specific thing. It's all about your. Now what do you think? Which came first, the bell or the crack? Which came first, the bell or the crack in the bell? Of course, the bell came first. It was without the crack. Later on, like how weathering happens, the crack came here. Okay. Now, what's your name? Dishan, read the vocabulary words.
Relative dating, superposition,
Superposition.
unconformity,
Yes.
fossil,
Hmm.
geologic column.
In this, I have explained you about relative dating. I've explained you about fossil. Fossil everyone knows. Now these three words, superposition, unconformity, and geologic column, these are new for you. Okay, let us go to another page first. Then we'll directly go to video because I'm going to finish this very quickly today. Now, imagine that you are a detective at a crime scene. You must figure out the order of events that took place before you arrive. You know, even in your English class, your teacher gives you mixed sentences and then she asks you which one is first, which one is second, and you try to arrange that in order. So similarly, you have to find out which event happened during the Earth history first. Instead of using fingerprints, scientists use rocks and fossils, determining whether an object or event is older or younger than other object or event. When you're comparing which one is new, which one is old, okay, that is called as, what is it called as? It is called as relative dating. Now, scientists know that gravity caused sediment to be deposited in a layer that are horizontal. Over time, different layers of sediment pile up on Earth's surface. Younger layer pile up on the top of the ones. You know very well. You are the one who answered me this. That younger layer, they pile on the top of the older ones. If left undisturbed, the sediment will remain horizontal layers. So these scientists use these orders to know the age of the rock or age of the.
Miss, sorry that I entered late, but the website and it did not work.
Who's that? Who just spoke?
Dana.
Okay, Dana. This approach is used to determine the relative age of sedimentary rock layers, the law of superposition. What is the meaning of superposition? What is the law of superposition? Again, you need to know it's important that the younger rock lie above older rock if the layers have not been disturbed. This is the law that if the younger rock is down and the older rock is on the top and they are left undisturbed, I cannot tell this if there is an earthquake. Do you think it will remain together? No, they will be disturbed. So if it is undisturbed and the younger rock lie above the older rock, if the layers have not disturbed, this is called a law of superposition. It's the opposite curl. The younger rock lie above the older rock. The down is the older and the up one is the younger one. Did you get it till here? The old picture, see, they are giving you an example. Over time, suppose that you have a brother who takes pictures of your family and piles them in a box. Over time, he adds new pictures to the top of the pile. Where are the oldest pictures? Of course, you can find them down. The ones taken where you were in a baby. Of course, that is down in the box. And where are the most recent pictures? That was taken last week. It has to be, the youngest pictures will be at the top of the pile. Layers of rocks are like photographs shown below. As you go from, like, see, he has piled up. So if you want to see the photograph when you were a baby, which photograph you will choose? You will choose a picture from down, not from up. Up, it will be that the latest pictures. Tilting happens when Earth's forces move rock layers up or down evenly, of course by earthquake or some other disaster. When does this tilting happen? When Earth's surface forces move rock layers up or down unevenly. The layers, they become slanted. Folding is what? Bending of rocks. That can happen when the rock layers are squeezed together. Maybe because of stress, maybe because of earthquake, anything. What is a fault? Girls, when this is the earth, any break in the rock, any break in the earth, on the earth crust, do you know the layers of earth? Inner core, outer core,
Yes.
mantle, and earth crust. If you find any crack on earth crust, on earth crust. This is called as fault. This is called as fault. A fault, if I ask you what is a fault, you must know that is a crack where on the earth crust or in the earth crust where rocks can move. An intrusion is an igneous rock that forms magma injected into a rock and then becomes hard. Okay, girls. See the white screen. This is the mountain. Okay, wait a minute. This is the mountain. Okay. Where is magma? Who will say me, where is magma? Magma is all inside. All right. When it comes down, even last year I told you, this becomes something like shiny gray color later on. So this all is lava. When lava cools, it becomes extrusive rock because its outside is extrusive. When this magma cools, it becomes intrusive. These are large sheets of marbles, beautiful, very shiny color. You can go to your kitchen slab and you can see there. It is magma, that means it is inside the rock. Folding, tilting, faults, and intrusions can make finding out. These all can tell you the relative age of the rock. What all can say you the relative age of the rock? All folding, tilting, faults, and intrusions can make findings out the relative of the rock layers difficult. Because of this folding and tilting, is it easy for me to find the age of the rock like before? No, because no more the layers are on the top. If I shake them, or if I bring some crack in them, what happened? It mixes with each other and then you don't get a proper age. So this is difficult. Scientists call this missing layer rock unconformity. It is called as unconformity. Till here, did you all understand? So what did we learn today? We learned what are intrusions. I told you inside the rocks. I told you what is tilting, what are faults, breaking of rocks, and what are foldings. You can see these layers. And then we studied about the superposition. That means the older rock is on the top and the younger rock is inside. And then unconformity. What is unconformity? When these faults and these cracks happen on earth, it is very difficult for me to find the age of the rock. So these they are not confirmed. They are not sure about the answer. So they say that this is unconformity. Okay, by this almost we have, tomorrow I'll finish this lesson when I explain, inshallah. So you just watch a video now. Can you hear the sound?
Yes.
Okay, let's continue.
Welcome to the lesson, Relative Dating. In this lesson, you'll explore how geologists can compare the ages of different rock layers and the fossils they find in those rock layers. The vocabulary words for this lesson are relative dating, unconformity, geologic column, superposition, and fossil. Click each word to learn more about it. Check out this fossilized animal. How old do you think the fossil is? It's hard to tell just by looking at this picture, isn't it? Let's see how scientists can determine the relative age of a fossil like this. What exactly is a fossil? Fossils are the preserved traces or remains of organisms that lived long ago. Fossils are most often preserved in sedimentary rock. Click the pictures to find out more about how fossils form and what we can learn from them. Can you see all the fossilized shells in this limestone? Some fossils, like these, form when minerals replace the hard body parts of dead organisms. Not all fossils form of an organism itself. Instead, fossils might form of footprints, dung, evidence of food storage or eating, and so on. This type of fossil is called a trace fossil. Trace fossils often give information about an organism's behavior, habitat, or diet. Fossils allow scientists to trace changes of a certain species of plant or animal over time. In this image from the U.S. Geological Survey, 3 fossils of the same species of coral were uncovered in the Drake Passage, south of the tip of South America. But what might make a scientist think these fossils are from different ages? Well, ancestral organisms can be fossilized in one rock layer. As time goes by and organisms change, the new organisms may become fossilized in another rock layer. In this way, fossils act like a record of the life forms that have existed on Earth. Suppose you're looking at a sequence of rock layers. Is there any way to tell which rock layer is oldest? Click the pictures to find out. These fossils formed at about the same time, so they are about the same age. Determining whether an object is the same age as, older than, or younger than another object is called relative dating. Sediment is deposited in horizontal layers on top of layers of older rock or sediment. As more sediment is added, it can be compressed into sedimentary rock. In this way, younger layers pile on top of older layers. This means that younger rock layers lie above older rock layers if the layers have not been disturbed. This rule is called the law of superposition. Due to the law of superposition, we know that fossils in lower rock layers are older than fossils in upper layers if the layers are
Because these are the eras. First, we say it is Proterozoic era or Paleozoic era, where you could only see the bacteria, and then plants came, and then dinosaurs were there, and finally we are in a Cenozoic era. So according to this, they find them in layers, and they say this is from this era. Maybe if they find some dinosaur fossil, they will say that it was from Mesozoic era.
Disturbed. Scientists have used this information to construct a geologic timescale that is the story of Earth's history. A body of rock or a fault or a crack might cut through another body of rock. If this happens, you know that the rock had to be in place first, before a fault or other body of rock could cut through a rock layer. This rule is called the law of cross-cutting relationships. It states that a fault or body of rock must be younger than any feature or layer of rock that the fault or rock body cuts through. Cross-cutting relationships are useful in relative dating. In this example, the darker rock intrusion is younger than the lighter rock that it has cut through. The rock layers shown here are pretty complicated.
See girls, this is unconformity. Because of the layers, it has cracked and it is not correct. Like, I told you fault. Fault means crack in earth's crust. If there is some earthquake or because of some disaster, these are mixed up because of, they told that tilting of earth. So that is called as unconformity. Of course, I cannot confirm the age of the rock. So I call it as unconformity. This is still here we have learned today. So thank you girls. Have a nice
Yes.
and see you all inshallah on tomorrow
Okay.
on Thursday.